Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today live with episode number 49 in our Shop Talk series. And what we're going to talk to you today about is we're going to be showing you a little bit about what we have coming down the pike on this channel. And so let's see, it looks like we've got some people tuning in here. Hello Rowan, Dang Dong, Eel, Rob, Rohan, we've got some people tuning in. We'll give people a little bit of time to get connected here. But what we are going to be talking about today is we have just finished up in our Python series of lessons. I think it was lesson number 20, where you got a really good introduction to the field of Python. And we went all the way through where you understood how to do functions, methods, classes, and threading. So you have a really good, those of you guys who are following along on that Python series of tutorials, you've got a really good working knowledge of Python. Now, I haven't shown you every single thing there is to know about Python, but I've shown you enough that you ought to be able to figure out anything that you need to do. You ought to be able to look it up now, that you should be familiar enough with Python that you could start doing things on your own. How many of you guys are actually taking that Python series? What is this, you guys? What is a huckleberry? Okay, a huckleberry is a little fruit, okay, but it was an old term that you used, like who's your huckleberry, like who's your special guy, who's the guy that can get the job done. It was an old saying, and so I sort of used that, and then people start using it back to me, and then some people wonder what we're talking about with all of this huckleberry nonsense. Okay, Pranav, welcome. GRC 5000, you know what a huckleberry is now. Vinay, Christopher, hey Christopher, good to hear from you. So we've got a nice group forming here, and like I say, let me know if you guys are working on, okay, Pranav says he's watching Python. Okay, thank you, Amanso. I am your huckleberry. Hey, Philippe, how are you doing? Good to see you always. All right, so let me see if I can come over here. And what I'm going to talk to you a little bit about is the direction that we're going to be going in the channel moving forward. Now, what we've done so far is we've gotten up to speed on Python, and now starting next Wednesday is when we start doing the 3D animations and the 3D graphics and the 3D visualization. So we're going to go from just writing code to starting to create visuals and starting to create graphics. So you can create these 3D animations of different things. Then after you get good at this VPython where you do the animations, then what we are going to do next is we're going to then connect Python on our desktop to the Arduino, and we're going to pass data back and forth, and those animations are going to come alive based on what's happening on the Arduino. So we could have a control panel where we could set dials and bars and so forth to make things happen in Python that then makes things happen on the Arduino, and then the data that the Arduino takes is going to come back to Python and bring those animations to life. And so I think that is going to be a pretty cool thing. So what I'd like to do is just kind of show you, you think, man, 3D animations, 3D graphics, that's way too complicated for me. But I want to give you kind of a quick introduction, just show you how easy it is. Now, in today's lesson, you're not going to be able to play along at home and follow along because you got to get the computer configured for it. And that's what I'll show you this coming Wednesday. I'll show you how to install the packages and how to get your system configured to do this. But then once you have that up and running, I would like to show you just how easy it is to do 3D animations in Python. Forgot to tell you guys to pour your coffee. Yep, I'm drinking water. I at least remembered a pink cup. The green one was disappearing on us last week, but I'm drinking water because it's evening time here and I can't drink this coffee. I enjoyed my coffee this morning, but now it is water time. Okay, so let's see here. The library that we are going to be using to do our 3D animations is VPython. So we would need to import that library. And I bet you guys would really, really appreciate if I gave you a view where you could see what I was talking about here. Okay, that looks pretty good. Okay. So if we're going to use the VPython library, we are going to need to what? From VPython import star. Where's my star? Okay. And this is just saying go to the VPython library and import everything. Now, I am just a little bit paranoid here, so I'm going to run this just to make sure that, okay, that ran. Just wanted to make sure I was right in the right environment where it did find the VPython, and so that is pretty cool. And then always it's useful to have import numpy as NP. You never know when you might need your old friend NumPy. And those of you guys who have taken some of my other lessons, we've used NumPy before, but it's basically just a package that allows you to do really complicated math really easily, okay? And then you never know when you might need to do some timing, so I'm going to import time, and that just allows us to put in delays and so forth should we need that. Okay. Now, what we're going to do is you guys tell me if we're going to create a 3D object or like a 3D shape, make a suggestion. What would be the simplest 3D object or 3D shape that we could generate? Somebody tell me a 3D shape that we might want to generate. I'm waiting. I'm looking at the chat box. Philippe, bam, look at that. Philippe is my huckleberry, okay? Philippe is my huckleberry. Okay, Dang Dong said a cube. Okay, so Dang Dong wants us to make a cube. So what we need to do is we need to create an object. And so I'm going to call it my cube because Dang Dong wants a cube. So I'm going to say my cube, and that is going to be equal to, well, the VPython object for a cube is a box. So I'm going to say create a box, okay, like that. So my cube is a box. Now the thing is, if I just ran this now, it would create the box and it would disappear because the program would stop running. And once the program stopped running, then the box would go away. And so we got to just keep the program alive. So we are going to say while true. When is true? True. True is always true. And then what we're going to do is just pass. And so this should just create an infinite loop that just sits there. So we're going to create my cube. It is going to be a box, and then it should display. So let's try to run this thing and see what happens. Okay. Boom. Okay. Now that just looks like a rectangle, but if I come up here and I rotate it around, you can see that we made a cube. How hard was that? Not very hard, I don't think. Okay. Now, so I said my cube is equal to box, and it just created a square box. What would maybe, if we wanted to get a little bit fancier, what would be maybe something that we would want to do with that box? Tell me something. Okay, so you've made a box, you made a cube. We'll call it a cube because that's what Ding Dong wanted to call it. But what would be something that might be nice that we could do with that cube? Tell me something like the simplest little thing to maybe make the cube a little bit nicer. Color, Eyal says. Okay, what color do you guys want? What color do you want? Somebody give me a color, and don't say fuchsia. Okay, give me a simple color. Looking for the first requested color. Okay, blue. All right, so what we are going to do, we are going to make it blue. So when we create it here, what we're going to do is we're going to say the box, and we're going to set parameters. The color is going to be equal to color.blue. Now, wouldn't it have been kind of cool if you could have just said blue, but no, you got to say the color is equal to color.blue. And now we are going to run it, and boom, we have ourselves a nice, shiny, fine blue. Pink, blue. Okay, blue was the first one, so that's what we went with. We went with the first one, and so there it is, and we have ourselves a beautiful blue cube. All right, a beautiful blue cube. All right, so now, ooh, big boggy face. How are you doing there, buddy? All right, I'll tell you, I love that cowboy hat you've got. I'm insanely jealous of your hat. I'll admit it. I'm insanely jealous of your hat. Now, what he said is change the color. Okay, let me see if I can change the color. I don't know if I can or not. I'm just going to see if I can. But let's see. I'm going to say my cube dot color is equal to color dot red. Okay, and then I probably need to put a rate in here because this would go so fast that it would change things so quickly. okay, it would change things so quickly you couldn't even see it. So I'm going to put a rate, a very slow rate of like 1. Okay, so that just controls how quickly it will go through this loop. So I'm going to say my color is equal to color.red. Okay, and then I'm trying to think here. I don't know if I can really do this. This is probably, I'm doing something I shouldn't do here. Let's say 1 time is equal to time.sleep1 and say my cube.color equal color.green and then time.sleep1. You see, I think that it really wants you to do this with a rate, and so I don't think it's going to like me doing that in there, but let's just look and see what happens. Okay, it's red, green. Boom! Look at that. Who was it? Big Boggy Face? A changing color cube you wanted and a changing color cube you got. All right, that is pretty cool. And well, now that we know it works, what we can do is we can say, okay, now we can say my cube dot color equal color dot, which one have I not done yet? We can go back to blue. Okay, blue, and then we'll go time dot sleep of 1 again, so that waits a second between them, and then we're going to come in here and we're going to run it again. Okay, and there we have red, green, blue, red, green, blue. Okay, so this is just something kind of I want you to see. You see, you set it up at the top with parameters, right? But then inside of your loop, what you can do inside of your loop is you can change. My cube is your object. What do I want to change on my cube? I want to change color. So then I say my cube.color and I can change it to something else. Okay, I can change it to something else. Okay, then I do believe that I heard somebody say, what else would we maybe want to change on this? Okay, somebody else tell me what we might want to change. Waiting. I know there's like a 10 or 15 second. Size, Ian says. Okay, size. That is also good. So what I'm going to do is inside of here, what I am going to do is I'm going to say a size, okay, is equal to, now what you have to think is a cube has how many sizes? It's got 3 sizes, like length, width, and height. Now the problem with length, width, and height, that's arbitrary, kind of like, well, what is the length? Is it this way or is it this way? Is it the longest one or is it the one going this direction? So we don't really think in terms of length, width, and height. We think of x, right? X goes this way and Y goes this way, and then Z, you go from X to Y and your thumb points in the positive direction of Z. And I know things are kind of backwards because I'm looking at you, so maybe if I go this way, if X is this way and Y is this way, then Z would come back towards you, back towards the camera. If I'm looking at a board and I go X, Y, Z comes back towards me. So that is how you know what X and Y and Z is. So you've got to keep in terms of X, Y, and Z, not length, width, and height, but it's going to be 3 numbers, and so that would be a vector. And what would be something that would be rectangular? Well, like a ruler. Well, let's say a ruler would be 12 inches long, so I'm going to make the X direction 12, and then the Y direction, that would be about what, 0.2, do you think? Like 0.2, and then I'd say about an inch wide. So in Z, which is like this, Z is going to be 2. Make it 1. Okay, does that sound good? Let's see if we make ourselves a ruler. Maybe I forgot to kill the last program. Okay, let's try it here. Okay, look at that. We made ourselves a ruler. Boom! How you like that? Look at that. Is that pretty neat? A 4D cube, yeah, right. You're not funny. You're not funny at all, Nicholas. Okay, get out of here, you aggravating thing. Look at all this nonsense I have popping up here. I need to turn those things off. They're getting quite annoying. Okay, so we've made something that has different colors, and we've made things that has different sizes. Okay, so let's see here. Let's come back over here. We'll close this now. All right, and then come over here and kill it. And so we were able to make something that was different, different colors and different sizes. And so I think that is pretty neat. Okay, now what I want you to do is I want you to think. Do you think that you'll just go through the rest of your life only wanting to make one object at a time? Or what do you think would be a good thing for us to do at this time? Instead of just one object, what do you think we should do? Somebody tell me. Okay, so, well, if it's not working for you, if you guys are trying to follow along, tune in on Wednesday, because it's not going to work for you because you don't have the libraries and dependencies and you're not configured right. I'm showing you what we're going to be doing over the next 10 to 15 weeks. I'm going to be teaching you everything about Visual Python. I'm just showing you today some things that are possible. Thaddeus Maximus, yes indeed. Okay, Thaddeus wants 2 objects and Ian is demanding a sphere. The people want a sphere, the people will get a sphere. So then I will call that my ball, and that is going to be equal to a sphere. Okay, and let's make it color equal color dot blue. Okay, I'm going to make it color is equal to color dot blue. And then I'm going, on a sphere, you wouldn't have size, you would have what parameter? Somebody tell me the parameter you would have for a sphere. I would need to set the what? I would need to set the what? Radius, Thaddeus says. Man, Thaddeus, you're on fire tonight. Or today, probably where you are. Okay, so I'm going to set the radius, and I'm going to set the radius equal to, let's just say 1. Okay, so I'm going to have color blue. And guys, I'm going to take the blinking color business out. Now I'm going to take the blinking color business out. Okay, so I'm going to take the blinking color business out, and now I'm just going to run this. Okay, so let's see. Boom, look at that. Okay. All right, Philippe, you were asking for a red sphere, and that would actually have been much better. And so let's go in and let's change that baby to red. So we are going to say the sphere is red, like that. Okay, so we're going to run that. If I didn't forget to kill it, I think I forgot to kill it. So now let's go here. Okay, look at that. That's kind of neat. That almost looks like a satellite or something, huh? I think that is pretty, yeah, Ding Dong said it looks like a satellite. I think that is pretty neat. Okay, now, what could I do dynamically maybe? Maybe what I could do dynamically is, and I'm going to turn my rate back up over here, maybe dynamically I could change the size of that ruler. And so I could do something like for I in range, I'm going to do an NP, numpy np dot a range, because I want to use non-integer, so I've got to use numpy for that. I'm going to start at 0.1, and then I'm going to go to 12, and I'm going to go in steps of 0.1. And so if I'm going to do that, I should start the size out at 0.1. The length is going to be 0.1, and then I'm going to start, and I'm going to go from 0.1, and let's maybe go to 6 here, not so much 12. We have a short ruler. All right, 0.1 to 6 in steps of 0.1. And then what will I want to do inside of here? Well, I think I've got to set the rate inside of every looping element. So I'm going to set the rate here again to 20, just so it knows how quickly to go through this loop. And so I'm going to say my box, and then I'm going to change its size. So dot size is the parameter that I want to change, and it is going to be a vector. Okay, and I'm going to be changing the length. So I'm going to change the length to I, which is my index. That's the number that's changing as I go through the loop. And then I'm going to leave it at 0.2, and I'm going to leave it at I'm going to make it 1.5, I think. Okay, so I'm going to make this 1.5 up here as well. Just tweaking my numbers a little bit. Okay, so I'm going to go from 0.2 to 1.5, okay, and then what I'm going to do is that is going to make it grow all the way to 6, and then I'm going to make it turn around and shrink. So I'm going to say for I in np.arrange, and then now I'm going to go from 6 back to, let's go down to 0.2, and then I'll go in steps of minus 0.1. Okay, so I go like that, like that. I think that looks pretty good. I just like things symmetric, so I'm going to do everything starting at 0.2. Okay, sizes. Now I am very confused what I'm, oh yeah, that's right, 0.2. Okay, so I go from 0.2 to 6 in steps of 0.1, and then I will go from 6 to 0.2 in steps of minus 0.1. Okay, does that make sense? And so that ruler should be getting bigger and smaller and bigger and smaller. Okay, let's see if that works. And we got to make sure we killed the old one, and here we go. Oh, we have an error, denied. What did I do wrong? Oh, for loops. Were you guys screaming at me over this? For loops or a colon. I hope somebody out there was yelling. Okay, and then I need to still set my box sizes. Okay, so this one will make the ruler get longer, and this will make it get shorter. So let's see what happens here. We're really hoping to see the ruler get larger. What happened to our ruler? Denied. Our ruler never got out of the ball. So what did I do wrong? Okay, so my cube is 0.2, 0.2, 1.5. I go from 0.2. I really don't know what I did wrong there. My box size vector equal vector I. Okay, I'm going to take that ball out of there just to see if I can see if there's anything at all happening underneath there. Do you guys see what I did wrong? Let's see. Okay, there is, but nothing is changing. Okay, nothing is changing, so we have a problem here. Okay, I'm just going to go back and make my size. I was getting too fancy there. I'm going to make it, I was getting too fancy. I'm going to go 12.2 and 1.5. I'm going to go from 0.1 to 12. And then I'm going to go in steps of 0.1, and then I'm going to say my box size is equal to vector, and I is my index, I, and 0.2 and 1.5, and then I'm going to go from 12 to 0.2 and minus 0.1. Rate is equal to 20, and my box dot size is equal to vector of I, 0.2 and 1.5. This really seems like, are you guys screaming at me? I hope you were screaming at me. My cube. Okay, my cube. Okay. Yes. Okay, now that I look at your comments, about 20 of you saw what I was doing wrong. Okay, so now let's look. Okay, boom, look at that. The ruler is getting bigger. And then let's see if it turns around. The ruler is getting smaller. Okay. Whew, that one was scaring me because I wasn't seeing what my mistake was. Okay, so now let's go back and go from 0.2 now that we see that it works. And we're going to go to 6, and we're going to go from 0.2, and then we're going to go here we're going to go from 6 to 0.2, okay, like that, and then we can turn my ball back on. All right, so now we should see something neat. Okay. Yes, look at that. Okay, so the ruler is getting bigger and the ruler is getting smaller. You see, I think that that is, yeah, bring back the ball. Yeah, we brought back the ball, Ian. Okay, look at that. I think that's pretty neat. Okay, now, what is another thing that we might want? We have a sphere and we have a rectangle. What would be another shape that we might want to make? Somebody tell me something else we might want to make. My what? My what? Somebody give me a suggestion. My pyramid. Ian, I just don't have a pyramid in me. I could make a pyramid. I just don't remember what it is. A cylinder. Yes, Philippe. I'm sorry. I can't make a. I could make a pyramid. I just don't off the top of my head have what the command is. But we're going to do a my tube is equal to, and that is going to be cylinder, and we're going to say color equal color dot green, and then we will want a radius, and I think a radius equal 0.5 would be pretty good, and then we're going to have a length of equal to 6, and let's just see what this does. Okay, let's hope this works. Let's give it a try. What I hope that you guys are seeing here is this is very logical. Okay, what happened? I killed it. What happened? It's not happy. It is not happy. What went wrong? Cylinder. Were you guys yelling at me? You've got to learn to spell right if you're going to program. Okay, let's go here. Okay, look at that. Okay, so we have... Now, if you look at this, it kind of looks a little bit like a what now? What does it look like? Looks a little bit like a thermometer, right? Looks a little bit like a thermometer. So let's see if we can kind of make it a little bit more like a thermometer. And I think one thing we would want to do is we would want to make the cylinder the same color as the balls. We're going to make them both red. Okay, we're going to make them both red. And now red like that. And then also the cylinder is 6. And then, okay, I think that would be good. Now let's just look at this and see what happens if we run this. Okay, so like you could almost think of this kind of being a little bit like a thermometer, but what do you not like here? Somebody tell me what you wish if this was going to simulate a thermometer a little bit better. What do you sort of wish here? Like, what do you not like? Somebody tell me what you don't like about this simulation if this were going to be a thermometer. Yeah, I could make this bigger. It's just I don't have that on the top of my head. It's a simple command where you change the scene, but I don't want to try to do that on the fly. Okay, nobody's making the suggestion. Yeah, go up only. Okay, I don't... Are you telling me to grow up, Ian? Did you just tell me to grow up? No, I think you meant go up only. Okay, I'm going to give you the benefit of the doubt there, Ian, and say that you probably meant just go up. Okay, not grow up. Okay, so what I want to do is, do you see that a rectangle, a box, is centered about the origin, and so its center point is at the origin. So when you change the size of a rectangle, it goes like this. The cylinder is different. The edge of the cylinder is the reference point, and the cylinder, when you change the size, goes like this. And so what I need to do is I need to offset the box or the cube by half its length or half its x dimension. And so what I need to do is I need to change its position in real time. So I'm going to say my cube and then dot position, and a position has 3 numbers, so it is a what? A vector. And I am going to go by I divided by 2 because that's the length, and then I am going to go 0, 0. So I'm not going to change the other dimensions. I'm not going to change the other positions, I'm only going to change the X position. And then similarly down here, I've got to correct it the other way. My cube dot position is equal to vector, and then it is going to be I divided by 2, comma 0, comma 0, like that. So let's see what that does if we do that. Let's hope that works. And I keep forgetting to kill the old program. Okay, let's see what happens. Boom, look at that. That is pretty darn cool, huh? And do you see how it looks like it's just really coming right up to that point that you want it to? Boom, and turning around. Okay, we really like that. I think I would like that ruler not quite so wide. It's sticking out a little bit too far. So up here on my cube, instead of having it, what was that, the 1.5? What if we said 1.2 there? I think that is the dimension, and maybe it won't stick out quite so much. Okay. Yeah, that's still a little bit more. Here comes my obsessive compulsive trying to get that exactly the right amount. Let's make it 1 and see what it like. 1.1. How about that? I think this is going to be good. Yeah, look at that. You see it just comes out just a little bit. I like that. I like that. Okay, let's kill that. And this was a... I don't like that because the cylinder was 0.5. I'm going to make it 0.7. I'm sorry you have to endure me trying to create the perfect. Okay, that is pretty good, I think. And I'm wondering, yeah, that looks pretty good. Just thinking, yep, I think that is going to be what we are going to go with, like that. Okay, so that's pretty good. I wonder, the size needs to be changed down here. That's what the problem was, right? I kept thinking it doesn't look like it's changing, so I think I'm going to put 1.1, 1.1, and let's see what happens there. You see, I was changing it when I created it, but I wasn't changing the one that was going up and down. That's what I wanted. Okay, do you see how that's just barely sticking out now? You see, that looks really like a thermometer now. I think that is really good. Okay, yeah, Big Boggy says if the sphere and the cylinder were white and the cube was red, you know what you really want? I mean, what you want is you want the sphere white and you want the cylinder white, and then you want a slightly smaller sphere inside of it that's red, and then a slightly smaller cylinder that is red, and then you want to set the opacity. I think opacity is what it is. Let's just see this. I hate doing this from memory, but let's just see if I can say that would be, let's call it my tube, and let's see if I can set opacity equal to 0.5. Let's see if that lets us look through it, but I don't know if that is really a parameter or not. There is something that you set opacity, but I don't know if that is it. Okay, yeah, I did it. Look at that. Okay, do you see how you can sort of see through the tube now? You can see through it. So let's go ahead then and let's make another ball. And so I'm going to say my glass ball, and that's going to be equal to this same thing here, like this. Okay, and now the radius is going to be just a little bit bigger, like 1.1. Okay, and the opacity is going to be equal to, let's say 0.5, and let's say color is equal to color.white. And I sure hope white is one of the colors they let me do. Okay, I'd hate for this thing to crash because it doesn't know white. Look at that. Okay, you see how we're starting to get a thermometer? We're starting to get a thermometer. So Big Boggy, do you see what I'm saying? We've got kind of like the red mercury inside of that. And we could sit and play with that opacity if we wanted to. But let's go ahead and let's fix the opacity on the tube. Let's take that out and leave that solid, and then we'll just create a new tube. Okay, so we're going to get this, Control C, and we're going to come here and Control V, and now the my tube, we'll call it my glass tube, is equal to color dot white, and the radius needs to be a little bit bigger, so we'll make it 0.6 like that. All right. Okay, let's see what happens there. I think I didn't set the opacity, did I? Yeah, my glass tube. So opacity equal 0.5. Kill it, and now let's run it. Alien thermometers are not visible. Okay, what is this nonsense? Why am I not getting any opacity there? All right, let's kill this. In my glass tube, opacity is 0.5. Opacity is 0.5. Cylinder color. Oh, color dot what? Was anybody yelling at me? What? Yeah, Mad G. Okay, you guys, it's not easy to code live on TV when everyone is watching. Okay, so let's go here. Okay. Now, is this pretty cool? Is this pretty cool? Now, what would be neat would be to make this full screen, and then you could see it a lot better. Okay, now what we could do is we could go in and we could put tick marks on it, and then we could put a scale on it. But also, you know what I think now? I'm going to do one more thing, and then I'm going to stop. Okay, I'm going to turn off this. So instead of okay, I'm just going to stop my ball. I'm going to stop my cube. Sorry, Dang, or whoever asked for the cube, but I'm going to turn that. I'm going to turn the cube off. And then what I'm going to do is, instead of my cube, it's going to be my tube. Okay, my tube is going to change. And this is really going to be like mercury going up and down if I'm not crazy. If this does what I think it's going to do. Hey, Visionary Robotics, welcome. Okay. Oh, that is not good. Something crazy happened there. Okay, so let's see. First of all, we're not going to do anything with position. That was a mistake. Okay, and then my tube size, and then what we're going to do is my tube, I think we're going to go length is equal to I, because it's not a vector for my tube. It's just a parameter, my tube dot length is equal to I. Now, I could be crazy, but this might work. Kill it, run it. All right, guys. You see that? Okay. So do you see how just kind of fun stuff, this isn't hard stuff, and you guys kind of stepped along with me. Do you see, like, we've made a glass thermometer with mercury? No, I am not going to bore you by putting the tick marks and the numbers on there, but can you imagine now we hook Python? Now, what I'll have to show you in future lessons, I'm going to take like 10 or 15 lessons to really teach you Visual Python, VPython. And then when you get really good and understand everything about it, then what we're going to do is we're going to install PySerial, and then PySerial will let our desktop Python send commands to Arduino and read commands back and forth. Just kind of like if you think the Arduino right now communicates to the PC over the little serial monitor. Well, instead of communicating over the serial monitor, it's going to be Python there catching the data from the Arduino and sending commands to the Arduino. Python's going to be doing that. And then this little thermometer, my friend, we could bring live based on temperature measurements that are being made from the Arduino. Then the other neat thing is once you get the data into Python, Python can launch emails, Python can do anything, Python can just put stuff on websites. So once you get the Arduino data into Python, then you can do anything with it. And so I think that this is a really, really cool. Wow, Claudio Benedetti, thank you so much. Really appreciate it. And yes, we will be getting some coffee with that. Really appreciate it. Or I might actually be paying my internet bill with that because my internet is getting kind of expensive out here. How is the quality? I'm streaming at 1080p tonight. 1080p and 30 frames per second. And is it coming through pretty clear? I hope it is. I hope it is coming through pretty clear. But I had a pretty good connection, and I thought, I'm going to see if I can actually stream at I'm going to see if I can stream at 1080, and it seems like maybe it is working okay. All right, so I think this is pretty neat. What I'll do is I'll show you kind of like some of the things you can do. This one isn't like a really beautiful graphic, but it just shows you kind of like the things that you can start doing, and I'll be showing you in the lessons on VPython how to do this. And so I think I will come here, and that is certainly not it. I think it is this one. And what I have done is, and I will show you guys how to do, I have made a clock, okay? And you see, the thing to see is, and it's actually showing the time, all right? And it's actually showing the real system time. So here it is 11 minutes after 7, and it even has the second hands running right. And if you look, kind of the cool thing, do you see how this minute hand is exactly right? It's not just jumping minute to minute to minute. It is showing fractional minutes up here, and then down here it is showing fractional hours. And the thing I want you to see is this is not a drawing. I want you to see that it's actually a 3D object. Can you see that the second hand is above the minute hand, which is above the hour hand? Or I think I put the minute hand under the hour hand, where really I think in a real clock the minute hand goes above the hour hand. So you can see that we have tick marks all the way around. And you guys, you got to really think about how to do this, because you see every tick mark is not just at the right position and not just the right size, it is at the right angle. And that's something that you have to kind of think about. And if you try to do it by trial and error, it won't work. You have to use your friend math, right? You would never be able to do this using trial and error. The only way that you could do this would be to do the math. And so this is what I'm going to do. I'm going to kind of take you through Visual Python until you can create these complicated compound animated objects where you're setting not just size, color, position, but you're also setting the orientation, which direction they're pointing. And so I'll show you how to do all that. Then when we do all of that, then what I'll be doing is I'll show you how to get this thing hooked up to the Arduino and then bring your animations to life based on data that you are taking from the Arduino. Okay, guys, this has kind of been a lot of fun. I hope you had as much fun as I did with this. The thing is, for me, I always was intimidated by 3D graphics, like it's really, really complicated. But it's just, you got to keep your orientation. You got to keep track of which direction X is, which direction Y is, and which direction Z is. And remember your right hand rule, so you know if this is positive X and this is positive Y, then positive Z would be back towards me. You go from X to Y, your thumb points in the positive Z direction. And you got to kind of keep track of that. We can make two clocks and quantumly entangle them. I think we should do that. I think that we should get a couple of clocks and see what happens if we try to sync them up. Okay, I think that is pretty good. Quantum library, yeah. I'm going to do is I'm going to take a few minutes and just see if I can answer some questions for you guys. I'm really excited, man. When I got over here to Africa, it was all I could do to just kind of like stay alive. You know, it's just like you didn't feel like going in and making live streams when, you know, you have the difficulty that we had for the first couple of months. But got everything pretty much under control here now. You know, go back and watch last week's video if you want to know some of the challenges that we've had, but got things kind of under control and ready to start making videos again. I'll tell you something else I'm working on. I'm starting to work some more on artificial intelligence. And I did that whole artificial intelligence series on the Jetson Nano. That turned out to be a challenge because when I did it on the Jetson Nano, the NVIDIA Jetpack, the operating system kept changing. OpenCV kept changing. TensorFlow kept changing. PyTorch, TorchVision, CUDA, all those different libraries and packages were changing. Wow, Philippe, you got to stop this. This is getting out of control, Philippe. Thank you, Philippe. Okay, this is so the problem with the Jetson Nano series was that so many things were changing. People are struggling with that series of lessons because for the things to work perfectly, you got to be on exactly the same versions of all the packages. So a lot of people are sort of struggling with that. What I want to do is like a series called AI for Everyone, Artificial Intelligence for Everyone, something that you could just do on a Windows 10 machine as configured and then start doing some pretty cool things. And that's what I've spent the last couple of days doing. And there's some pretty cool things that I'll have to show you. And so maybe if you guys are interested, next Saturday in the live stream, I could show you some of the things that I'm doing with artificial intelligence. It's not something you could follow along with. It's not something I would be teaching. It would just be me showing you what I'm going to teach you as we get finished with this Python stuff. That the next thing maybe what I would do is artificial intelligence for everyone. The good news is it runs in Python. Okay, so all this stuff that you've learned in Python, now as I'm teaching you artificial intelligence, you're like good in Python, and so the stuff would make sense. Okay, so all right, let's see. Big Boggy Face, can you make colors that aren't listed colors? Yes, Big Boggy Face. You know what you do? You do like a color is equal to vector and then R, G, B, and those RGB values between 0 and 1. And so like if you wanted to turn on red, it would be color is equal to vector, like box.color is equal to vector 1, 0, 0, and that would be red. But that if you wanted something like yellow where you're mixing two other primary colors, then you would have it like 0.5, 0.50 or 0.50, 0.5. So you could create any color of the rainbow by taking RGB between 0 and 1 and varying what they are, and so you can create any color you want. And I have to admit, I get a little frustrated that I think the only thing they really know, the only colors VPython knows directly with a word is red, green, blue, cyan, magenta, yellow, and orange. So just those primary colors and orange. I don't even think it will do purple. Okay. So anyway, yeah, machine learning, simple machine learning, that would be good too. But I want to do things that would be kind of really fun, like a high pizzazz factor, like a whole lot of fun. And yeah, you got to learn something, you got to pay attention and stuff, but not like something just crazy impossible. And I think I found some stuff that would be both really cool and really fun. And the other good thing is it's not like you're going to learn Python and then, oh, you got to do something completely different. Most of you guys started with Arduino, and then from there you're learning Python, and then Python and Arduino working together, and then we go to machine learning and artificial intelligence, and then that's going to be in Python, so we're drawing on that. And who knows, maybe the artificial intelligence in Python might then go back and be talking to the Arduino and making the Arduino do things. So I think that might be kind of interesting. Infrared, that way you can have a control panel in the dark without making visible light. Yeah, there are some interesting possibilities there. Can you put a background photo to the animation? Yes, certainly you can do that. And I mean, it's a lot like some of this stuff that we're doing here, some of this stuff that we are doing here, like with the green screen, those types of things we can do in Python, and we can create our own like image manipulation stuff where we can suck the background out from behind us and put whatever we want. But rather than using these CAN packages, we can do it on our own. I'm sorry, I can't pronounce things better. I will not be doing a drone series because a drone, my friend, is a flying blender. And I'm not going to teach you to program a flying blender and then you go fly your blender into your neighbor's face and then everybody comes looking for me. No, I want no part of that. I try to do things where, people can't hurt themselves. Like I love drones and I build drones and I play with drones, but you can kill yourself or you can kill someone else with a drone. So I will not be doing something like that. I am not really sure about chatbot. It's not something I have done a lot with. Self-balancing two-wheel car. Ding dong, I've always wanted to do that. But I just haven't. One of these days I will do the self-balancing car. I did a cool project kind of like that once where I had a little steel marble that was a magnet. So imagine a spherical magnet. And then up here, I had an electromagnet. Okay. And then I had a Hall sensor, and that Hall sensor could detect how far away the steel magnet was from the electromagnet. Okay. And then I set up this just insane PID controller, and the Hall sensor, if it sensed that the spherical marble was dropping, its signal was getting weaker, the power to the electromagnet was turned up to bring it back up. But then if it was getting too close, it would turn it down. And that little steel magnet just floated itself suspended in midair. But that is really, really hard because as far as a PID, proportional integrated derivative controller goes, that is an insanely hard thing to tune where that marble just stays still. It's like a very, very unstable system. That was probably the hardest little fun project I ever did, and actually got it to work. Okay, so let's see. I've got the IMU series, levitating ball. Okay, there's some fun stuff. There is indeed some fun stuff that we can do. And let me see where we are here. Let me see where we are. I'm sorry. One of the problems I have is I used to, in my studio, have 4 screens. Yeah, that was a mess up. I used to have 4 screens, and now I'm just operating my studio and my coding and my YouTube control panel with just 2 screens. And it turns out to be kind of hard to do that. And so then I have to close windows because I can't have them open at the same time. And then what happens is I end up where it's kind of hard. It's kind of hard for me to find. So anyway, that is where we are. Let's see. Looks like we had a nice turnout tonight, and you guys had some great comments. Looked like most of you were on your best behavior. I think the people that were kind of making themselves a nuisance just finally got tired and went somewhere else, and I say good riddance, but it looks like you guys were on your best behavior. It has been fun, and I think at this time, what I'm going to do is I'm going to go ahead and wrap this thing up, and then hope you guys will tune in next week, because I hope you thought that the stuff that I did today was pretty cool, and then next week is going to be even cooler, and I just have some crazy ideas of where I want to go between this visual Python, this VPython, these 3D graphics, and that's kind of like not artificial intelligence. That's more like virtual reality. You can create virtual 3D environments, and kind of this melding of virtual environments with artificial intelligence, and it just seems like some really, really exciting things that we could do. Okay, guys, I am going to let you go. video. I want everyone to, on 3, click the thumbs up button, because that really helps me. It helps me with the old YouTube algorithms. It also helps me after the video if you will leave a comment in the video. That'll help me. If you haven't subscribed to the channel already, make sure you subscribe. When you do, ring that bell so you will get notifications when we have new events and live streams. So this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.